All right, we're going to quickly talk about Unit 731, and we're going to start off by doing long division of polynomials. So if I'm trying to divide this right here, this polynomial, this one right here in example 1, by this x minus 2, right, where x minus 2 is the divisor, we can actually write it out like that, okay? Now, when we write it out like that, to figure out the first term that goes right there, okay, what we're going to have to do is we take the leading term here, which is x cubed, and we're going to divide it by this leading term in the divisor, which is going to be x. All right, so that's going to give me an x squared, and this is how they came up with this number right here, all right? Or that letter, I should say. And then now we're going to distribute that x squared times that x. So it's going to give us an x cubed. X squared times negative 2 is going to give us a negative 2x squared, right? And the goal here is to just like, and that's basically how I came up with that. I didn't notice that was already written there for me, but so that's how I came up with that. All right, and then what I'm going to do next is I'm going to subtract it. When I subtract x cubed minus x cubed, that's going to cancel, which is what I wanted. That's good. That negative right here with this negative would make this into a positive 2x squared. So when I subtract a negative 2x squared, it becomes a positive, so that's going to add up to a 6x squared. All right, and then we're going to drag the next number down. All right, we're going to do this all over again. All right, so where we take the leading term, which is 6x squared, and then we're going to divide it by the leading term in the divisor, which is that one again, okay? So we're going to divide this by x again. Nothing else matters, just those leading terms. So that's going to give me a 6x. We're going to write a 6x right here. And then now, just like before, we're going to distribute this into here. So 6x times x is going to give us a 6x squared. And then 6x times negative 2 will give us a negative 12x. Now, don't forget, we have to subtract this. Okay, and if you happen to remember long division, this works pretty much alike, right? 6x squared minus 6x squared is going to cancel. This negative right here will make this into a positive, right? So that would actually give me a negative 5x minus a 12x, which is going to give me a positive 7x. And then we're going to drag down this negative 14 at the end. And then we're going to do this all over again. This leading term right here, we're going to grab this leading term. And then we're going to divide it by the leading term in the divisor again. So that's going to give me a positive 7. All right, so we're going to write a plus 7 here. And then we're going to distribute again. So we have 7 times x is 7x. And 7 times 2 is negative 14. And then we're going to subtract. So 7x are going to cancel. The 14s are also going to cancel. So I end up with a remainder of 0. All right, and if you look at the steps, if you want to, this is actually the same steps that I draw on here. Now, one thing to note, right, and part of the reason why we're doing this is if you get a remainder of 0, that means that x cubed plus 4x minus 5x minus 14 has a factor of x minus 2, right? Meaning that if the question was, is x minus 2 a factor of the original polynomial, the answer would be yes. Also, in addition, the fact that this gave us a remainder of 0 means that this would be a root, all right? X minus 2, remember, don't forget that a root would mean an x-intercept. Remember, the word 0, root, x-intercept, they all mean the same thing. So this actually has an x-intercept at 2, okay? Now, as we go on, we're also going to do something called synthetic division. So notice that we have the exact same problem where we're basically dividing this function like this again. Now, we're going to do another system called synthetic division. And to do that, the first thing I have to do, for example, is I have to set my factor, which is x minus 2, set that equal to 0, and I get a 2. And that's the number that goes right here. Now, notice that the rest of these numbers that are right here, they're actually the coefficients of this right here, right? They're the coefficients of this polynomial. So that's what you do first. Now, what you're going to do first is you're going to drag the first coefficient down, and that's what they're doing here, okay? And now the next thing is you're gonna multiply that 2 and that 1. So this 2 times this 1, and you're gonna put that number right here, which is 2. And then you're gonna add the 4 and the 2, which is 6. And then we're gonna do it again. We're gonna multiply that 2 times that 6, and that's gonna give us a 12. All right, so we have -5 plus 12 is equal to +7. And then we're gonna do it again. 2 times 7 is 14, and -14 plus 14 is 0, so a remainder of 0. So now, what we just did is we divided this using synthetic division, and the way to write this answer, what that means is that since I am dividing by x to the first, and this is originally an x cubed, I'm going to start off with an 1x squared plus 6x plus 7, and since it has no remainder, that would be the answer. Notice that this is the exact same answer as what I got when I was doing this via long division, all right? That's the same answer right here. So 2 ways of doing the same thing. Now, the only restriction you have that if you're using synthetic division, your divisor has to be linear, meaning this right here cannot be like an x squared minus 2 or a x cubed plus 4, whatever it may be. This x has to be to the first power, and if it's not, then you cannot use synthetic division, all right? So with that, there's actually a couple things that I could say. There's all these theorems right here, but I think I would rather explain some of those theorems in the context of the exercise. So I'm gonna go to a different page because quite honestly, for the first at least 7 problems, you don't have, actually pretty much almost every problem, you don't have enough room, right? So on this separate piece of paper, I wrote this exercises. So one more time, let's just do one, and maybe you can kind of do it on your own, this exercise, so you can see if you can. So for example, in this one, we're dividing x cubed plus 8 by x plus 2. Now, about the only difference between what I did there, I'm gonna choose long division. You actually have a choice whether you want to use long division or synthetic. So I would advise for you to at least write zeros for the letters that I do not have, meaning the coefficients, right? Notice that I have to write those as a placeholder. Otherwise, then that's gonna throw me off in the spacing of this, right? So just like before, remember, and I'll do this one. And I would say I'm gonna do this one this way. Maybe you need to do it with synthetic division or do this with long division again so you can see. Or I would even encourage you for you to pause and see if you can do this on your own, and then you can just unpause me and then see if you got the same answer, right? So we're gonna take this leading term, which is x cubed. We're gonna divide that by x. That's gonna give us an x squared, meaning that's gonna be my first number. So I have an x squared here. We're gonna distribute that x squared here, so we have x cubed, and then here, which is gonna give us a plus 2x squared. All right, let me erase that so I don't have to deal with it later, right? And don't forget, we're gonna subtract this. So that's gonna give us, remember that negative is gonna cancel the x cubed. This negative also distributes to that positive, making it a negative 2x squared. And then we're gonna drag the next term down, so plus 0x. All right, we're gonna do it again. We're gonna take that leading term, which is negative 2x squared. We're gonna divide it by the leading term in the divisor. So we have a negative 2x. All right, we're gonna do that again. So negative 2x times x is negative 2x squared. And negative 2x times 2 is negative 4x. We're gonna write this in parentheses. We're gonna subtract it. The 2x squares cancel. This negative will make this negative 4x into a positive 4x. And then we're gonna drag the next number down, all right, which is an 8. And then when I do that, again, we're gonna take the leading term, divided by the leading term in the divisor. That's going to give us a 4, so this last term should be a 4. So again, if we distribute 4 times x, that should give us a 4x, and then 4 times 2, that's going to give us an 8. And if I subtract it, I happen to get a remainder of 0, right? So that's the answer for that one. Now, on this next one, I would suggest for you to do it, say, long division or synthetic. It doesn't matter, but let's use synthetic just for the sake of practice, right? Remember, for synthetic, you're going to set this factor equal to 0. and then we're going to solve. So that's going to give us a -2. All right, we're going to write the -2 on the outside. And then we have a 2x cubed. Oh, excuse me, that's not right. Just write the coefficients. Minus 3x. Notice that I don't have an x term, so I'm going to write that as 0x, which is 0 here and a 4 here, right? So again, we're only writing the coefficients, okay? We're going to drag those two down. Now, don't forget that what we're going to do here is we're going to multiply that -2 over here times that 2, and that's going to give us a -4. And by the way, I wrote up x here. I shouldn't have done that. So it's a -4. That's going to give us a -7. -2 times -7 is positive 14. All right, so that's going to add up to be 14, and that's going to give us a -28, which is going to give us a -24 as a remainder. Now, here's the part where I teach you how to write a remainder. So remember, the answer is always going to be 1 degree. If you're using synthetic division, it's going to be 1 degree less. Remember, degree will be the highest power of this polynomial. So 1 degree less, or 1 power less, should be 2x squared, and then you just go in order from there. So you go from x squared to x to the constant, and to write the remainder, you would write plus negative, in this case, only negative because it's -24, -24 over x plus 2, okay? So that's that. I would encourage you to do number 3 on your own. I can give you the answer if you like, so you can see the answer if you do it either way, whether with synthetic or long division. Although I think if your divisor is a linear function, I think this is faster if you do it with synthetic. This is what you should get, so I would advise try it out, or I'm not going to do it for you. Just try it out. Now, this is where we're getting to some of the theorems that we talked about, right? If the question is x minus 5 a factor of this polynomial that you see in front of you? It looks like I'm missing a term here. It looks like I'm missing an x to the 4th here. Let me check. Yep, I was missing that term right there. So make sure you write it. All right, so to figure that out, okay, one way to do this, because to factor this is actually very difficult, right? So if you just want to know if x minus 5 is a factor, what you could do is to divide it, right? So we can divide that polynomial by that factor. Now, because I personally think that it's easier with synthetic, I'm going to use synthetic division to divide it. All right, so this will answer that question that you have here, right? So we're going to use synthetic division here. Drag the first number down, let's see. And I'll tell you what the results means, all right? So we have 5 times 1 is 5. This is a 2. 5 times 2 is 10, so that's going to be a 17. 5 times 17 is 85, and 85 plus a -60 would be a positive 25. And then 5 times 25 is a positive 125. All right, so here's the deal. If your remainder is 0, okay, then, so I'm going to write it over here. So this is part of the remainder theorem, by the way. So this is FYI, this is a remainder theorem. All right, if the remainder theorem says that if your, what do they call that? If my remainder is 0, is equal to 0, then that implies that x minus 5 is a factor of that polynomial. All right, so that's actually the great news. That's actually what makes it easier. Now, the remainder theorem also goes as far as making something else a little bit easier, right? So the remainder theorem, factor theorem, for example. Okay, so this is sort of related to the remainder theorem and factor theorem. For example, if you look at number 5, it's just asking you for p of -1. Now, of course, what that means is you could plug in a -1 here. You know, you could plug in a -1 like that if you want to, but I'm not going to do it that way, all right? Because the remainder theorem also tells me something else that I think is very useful. The remainder theorem also says that if instead of plugging the -1, if I actually divide using synthetic division, let's see, I don't have any zeros here. Remember, you only write zeros for the coefficients if you don't have one of these terms. So since I went from x cubed to x squared to x to the first power to constant, then we're good. All right, so we're going to drag the 1 down. So negative 1 times 1 is negative 1. That's a 3. Let's see, negative 3 times negative 1 times 3 is negative 3. So it's negative 5, and then negative 1 times negative 5 is positive 5. This is 0. Okay, so the remainder theorem could also tell you, right, if I don't know what that was, this right here, whatever the remainder is, whether it's 0 or not, all right, that would be the answer to this question right here, which is actually super useful, especially when we don't have a calculator, all right? So again, the remainder theorem can tell you that. Now, the next question took our class a little bit because we weren't thinking, all right? The idea behind it here, it says 1, 0 of this function that I just did, by the way. This is just p of x, all right? So number 6 is just still talking about the same function, p of x. So one of the zeros is asking for one of the zeros. Well, one of the zeros is what I just found, right? I found a 0 here, which means that one of the zeros is located at x is equal to negative 1, all right? Don't forget that a 0 of a function is the same thing as an x-intercept, and that's the same thing as a root, all right? So if I ask you for a root of 0 and x-intercept, I could do it that way, all right? Now, number 7 gets a little bit more complicated because it's asking me for another root of x cubed plus 4x squared minus 2x minus 5. So same problem, this is still asking me for another root. Now, notice that I didn't write this. I wrote it like this. Why did I write it like this? Well, because since I know that x plus 1 is a factor. Now, how do I know that x plus 1 is a factor? Because if x was equal to negative 1, that means that x plus 1 was the factor that I was looking for. All right, so by the remainder theorem, that means that this right here, if you were to multiply all of that, I actually get back to p of x, okay? So I already know one of the factors is x plus 1, all right? The other factor is x squared plus 3x minus 5. So, this one I can very easily set this equal to 0. So this is x is equal to negative 1. That's great, all right? Now for this one, I would have to figure out a way to get the zeros from that. So remember, to find the zeros, you have really two options. You can try to factor, and if factoring does not work, then the only way to do this is by doing the quadratic formula, all right? And this one right here does not work by factoring. So you're forced to use the quadratic formula, whose formula I'm writing here. Square root of b squared minus 4ac all over 2a. Okay? So if I do that, let's see, and again, let me just see what I got here. So I would have a negative 3, by the way, I'm using this equation, okay? So we have negative 3 plus or minus 3 squared minus 4ac all over 2a. 2a would be 2 times 1, all right? That would give me a negative 3 plus or minus the square root of 29. And let's see, that's 9 plus 2, that's 29. Which, by the way, 29 is a prime number over 2. And I can't really do much with that. But notice that I have one root here. And this counts as 2 roots. Okay, and if you look at the degree of the function originally, that was degree 3. I have 3 roots, so I know I'm doing this right. Now, as far as once I get into number 8, I have to actually do what's called the rational zeros theorem, which is actually more involved, and we're going to use the skills that we have so far, right? So for that, I will make a separate video because it does take some time to do. All right. However, nonetheless, I'll put some links to some videos for some extra practice on the long division of polynomials and synthetic division, and hopefully that'll help, okay? So on the homework, try to do as best as you can, and I'll cover the rational zeros term on the next video.